How do you even find R equivalent when you are not able to decide in first place which resistor is in series and which is in parallel? So James, looking at such combinations, ever wondered how do you even decide which resistor is in series and which is in parallel? Yes, that is exactly what we are going to discuss today. And by the end of this video, you'll be able to solve such type of combinations by yourself without any hesitation. So let's dive into it. So let's directly begin with a question today. Okay, we'll learn the approach side by side. So here you are given a simple circuit. You are supposed to find R equivalent across A and B. Okay, so this might seem as a series combination, but it is not a series combination. Okay, here we are supposed to follow these three simple steps in order to decode this circuit. Okay, and in order to find R equivalent. Okay, so some of you who might have seen the video on combinations of capacitor might already be familiar with this approach. Even if you are not, it's okay, we are going to revise it over here. Okay, so step one, let's dive into it. So step one is to assign potentials. Okay, you will assign potentials at every node. At every junction you are supposed to decide what is the potential. Okay, you can assign any random letter, okay, and that will be the potential at that point. Okay, suppose we say the potential over here is B. Okay, so that B is the potential at that point. And one more point you are supposed to remember over here is that 2 points which are connected by a connecting wire will have the same potential. I'll repeat that, 2 points which are connected by a connecting wire will have the same potential. Here you can see that these 2 points are connected by a connecting wire, right? So they will have the same potential. There will be no drop across the wire basically. So potential, suppose over here we decide the potential as B. Okay, we have assigned a potential over here B. Okay, so here also the potential will be B, here also it is B, and here also it will be B. Okay, 2 points which are connected by a connecting wire will have the same potential. Okay, so now let's assign the potential over here at this node. We'll call the potential over here as A. Okay, we'll call the potential over here as A. Okay, so if you can see, these 2 points are connected, this and this are connected by a connecting wire again, so they will have the same potential. Okay, there will be no drop across this connecting wire. So this since the potential over here we have assigned it as A, here also the potential will be A. Okay, so first step, assigning potentials, done. Okay, and in that we have to just remember that 2 points which are connected only by a connecting wire, they will have the same potential. Okay, so yeah, first step is done, assigning potentials done. Now step 2 is to draw a simple circuit. Now we cannot decode this circuit, right? We are not able to decide which resistor is in series and which is in parallel. So we are supposed to draw a simple circuit over here wherein we'll be able to decide which one is in series and which one is in parallel. Okay, so for that you have to treat A and B as terminals. You have to treat these 2 points as terminals. Okay, across which you are supposed to find your resistance, equivalent resistance A and B, right? So these 2 points you will treat them as terminals. Now you don't have more points over here. In the upcoming problems, the problems that we have, you'll have more points. Okay, here we only have A and B, right? Everywhere we have A and B. In the problems that we are going to discuss, there you'll have more points like C, D. That time you have to keep in mind that you are supposed to treat A and B as terminals, and if you have more points like C and D, they will be squeezed in between. Okay, so this is the crucial point over here. Okay, if you have more points, you'll squeeze them in between. Anyways, we only have A and B over here. Okay, in this combination you can see everywhere at every node we only have A and B. Okay, so we have written A and B. You can see that this resistor, now drawing a simple circuit. Okay, so this resistor is between A and B. So let's draw it. This resistor is again between A and B, right? You just flip it. This is again between A and B, right? So you draw it over here. Okay, so if you see, all three of them are between A and B, A and B, A and B, right? So it means that they are across the same potential or they are in parallel combination. Though they seem to be in series combination, they are in parallel combination, right? So this resistor is also between A and B. So this is how you draw a simple circuit. And if you see this, all three resistors are in parallel, and the equivalent in this case will be R by N, right? So identical resistances in parallel, it is given by R by N, where N is the number of resistors and here it is by 3. You can also use the reciprocal formula if you want, but this is the answer that you will get. Okay, so I hope the approach is very clear. Let's just go through it once. First step is to assign potentials. You decide potentials at every node, okay, at every junction. Okay, so remember that 2 points which are connected by just a connecting wire will have the same potential. So if the potential over here is A, potential over here will also be A. If the potential over here is B, this is connected at this point. Okay, these 2 points are connected by connecting wire. Potential over here will be also B. Second step is to draw a simple circuit. You are just supposed to see where is the resistor connected. You can see that this resistor is between A and B. This is also between A and B. This is also between A and B. So the combination is of this type. Or you can see that all three of them are connected between A and B, which means that they have the same potential difference across them, or they are in parallel combination. So the equivalent basically becomes R by 3. Okay, so that is the simple way of doing it. So let's move to the next question now. It will get more and more clear as we do more problems. Okay, so please note down the approach somewhere. Let's move to the next question. So question 2, the intro problem over here, and yes, we are ready to solve it now. Okay, here you are supposed to find R equivalent across A and B, okay, across these 2 points. Each of the resistor over here has resistance R, okay. So you can try it out. I hope you have noted down the approach somewhere. We are going to use it in every problem now, okay. So let's follow the approach. Step 1 was to assign potentials, right? So assign potentials at every junction, okay. So here we'll call the potential over here as A, since it's given in the question. This is point A, so here the potential will be A, and here let's call the potential as B. Okay, you can see that these two have a resistor between them, right? So they will have different potentials at the end. Okay, there will be potential drop across the resistor, right? So here the potential is A, here the potential is something different, B. Okay, now let's assign the potential over here. We'll call the potential over here as C. Okay, we can assign any letter. So potential over here is C. You can see that this point and this point is connected by a connecting wire, which means that potential over here will be also C, right? There will be no drop across this line. So you can see that if the potential over here is C, potential over here will also be C. Okay, so step 1 done. We have assigned the potentials at the junction. Step 2 is to draw a simple circuit. Draw a circuit which you and I understand, right? So let's draw it, and we have to keep one thing in mind, that we are supposed to treat A and B as terminals, right? We are supposed to find R equivalent across A and B. So A and B are terminals, okay? And point C will be somewhere between them, right? So A and B are terminals and point C will be somewhere in between. Okay. So now let's look at every resistor and see where it is placed. Okay. So if you see this one, this resistor is between B and C. Okay. So it is over here between B and C. Okay. So this has a resistance R. Okay. Each of them have a resistance R. Okay. So this is between B and C. So this one done. If you see, this one is between A and C. Okay, so let's draw it between A and C. Okay, now this one, if you see, it is between A and B. Okay, so from here till here, okay, between A and B. Now let's come to this one. Again, this is between A and C, right? So between A and C, we can draw it this way, between A and C. So these two are in parallel, right? So this one also has resistance R. And finally, we have this one, which is again between B and C. Okay, so this is between B and C. So this one and this one will be in parallel. So this is between B and C. Okay, this also has resistance R. Now you can see that it is a simple circuit. These two are in parallel, these two are in parallel, then their combinations will be in series and again in parallel with this one, right? So let's just speed run it. So R equivalent in this case, R and R in parallel gives you R by 2, R and R in parallel gives you R by 2, R by 2 and R by 2 in series will give you R, R and R again in parallel will give you R by 2. I hope you were able to follow. Okay, so if you see over here, it's R and R, right? In parallel, they will give R by 2. So R by 2 over here, again R by 2 over here. Okay, so this 2 will be in series and the combination will be in parallel with R. So this is R by 2, this is R by 2, they are in series. So series combination of R by 2 and R by 2 will give us R. Okay, and then again R and R in parallel will give us R by 2. Okay, product upon sum. Okay, that will give you R by 2. And that's our answer. Let's move to the next question. I hope it was easy this time. So question 3 over here, again the question is not really changing. You are supposed to find R equivalent across A and B. Okay, so here is your circuit, here is your combination. Find R equivalent across A and B. Okay, you can pause the video here and give this a humble try and discover the joy of doing it yourself. Okay, so step 1, assign potentials, right? So we'll say that potential over here is A, potential over here is B. Okay, and if you see this and this is connected, so here also you'll have potential A, here also the potential will be B. And if you see this point and this point is again connected by a connecting wire, which means potential over here is A and potential over here is B, right? If you see, this point is directly connected over here, right? These 2 points are connected. Since the potential over here is A, potential over here is also A. Okay, this point and this point are connected. The potential over here is B, so here also the potential will be B. Okay, so if you see, we don't need any more points for the nodes. You can see that all of the resistors are between A and B. This one is between A and B, this one is between A and B, these two are in between A and B, these two are in between A and B. This just means that the wire goes on top. Okay, there is no connection between the two. Okay, it goes from top. Okay, there is no connection over here, it shows that. Okay, so if you see, all of the resistors are in between A and B. Okay, so let's draw the simple circuit if it's not clear. So we have A over here, we have B over here. Okay, no more points. And this resistor is between A and B. Okay, 4 ohms. Then we have these 2 resistors. Okay, this one is done. These 2 resistors between A and B, right? This 2. So 2 and 4 ohms between A and B. So 2 ohms. And then 4 ohms between A and B. Now we have, so this 2 also done. Then we have 8 ohms and 6 ohms again between A and B, right? So this 2, let's account for them. So it's 8 ohms and 6 ohms, right? So 8 ohms and 6 ohms. Okay, and finally again we have 4 ohms between A and B. Okay, so let's connect it this way. So 4 ohms. Okay, so you can see that all of the resistors, all of this, this is a combination that you are supposed to find and find R equivalent, right? So it's very simple now. You can find R equivalent by using the parallel formula, right? So it will be 1 by 4 plus 1 by 6. Now this are in series, right? 4 plus 2, 6, and that is in parallel with all the others, right? So 4 plus 2, 6, and that is in parallel. So using it in the parallel combination formula. So 8 plus 6, that is 14. So again, add that, add its reciprocal plus 1 by 4, right? So 1 by 4, 1 by 4, that is half. Okay, so half plus 1 by 6 plus 1 by 14. You can take half common. 1 plus 1 by 3 plus 1 by 7. Okay, you are just supposed to solve it now. 1 upon R equivalent is 1 by 2 into 3 sevens are 21. 21 plus 3 plus 7, 21 plus 10, it's 31, right? So 31, and R equivalent will be, so you just have to cross it, so 21 into 2, 42 by 31 ohms. Okay, so 42 by 31 ohms is the correct choice, okay, is the correct answer over here. So if you did get it, congratulations. Even if you didn't, let's move to the next question. Okay, I'm sure you'll be able to do the next one. Okay, so let's move to the next one now. So question 4 over here, let's solve it. You are again asked for the equivalent resistance between A and B. Okay, each of this resistor has resistance small r. Okay, so step 1, assign potentials, right? So we have to assign potentials at every junction, here, here, here. Okay, so you can see that this point and this point is connected, which means the potential over here will be B. This point and this point is connected, again the potential over here is B. Here again, if you see this point and this point is connected, you can see that there is no resistor or any circuit element in this segment, right? So everywhere the potential will be B. Okay, so B, B, B. Okay, now here let's assign some random potential. Okay, let us call that A. Okay, A, or A is over here, so let's call that O. Okay, the center of the circle. Okay, so here the potential is O. Okay, so you have 3 points A, B and O. Okay, so you are supposed to treat A and B as terminals, right? Step 2, treat A and B as terminals, draw a simple circuit. Okay, these 2 points as terminals, and one more point we have O, let's squeeze that in between. Okay, so now draw a simple circuit, look for the resistance, where are they connected. So let's look for this one. You can see that this is between O and B. Again, this is between O and B, this is between O and B. Okay, this is between O and B. Okay, if you see, this is also between O and B. Okay, this is also between O and B. Okay, each of them has a resistance small r. And finally, we have one resistor between O and A, right? This resistor is between O and A. Okay, so we have a resistor between O and A. Okay, so you can see that these three are in parallel. Okay, these three are in parallel, which means they are equivalent will be R by 3, and that is in series with this one. So finally, R equivalent will be R by 3 plus R, right? R by 3 plus R, so that will be 4R by 3, right? Yes, so 4R by 3 is the correct choice over here. Let's move to the next question. So question 5 over here, it is from JEE Main 2021. Okay, so make sure you pause the video over here and give this question a humble try. Okay, here are your options. Okay, so question is the same. You are supposed to find R equivalent across A and B. Okay, so I'll do it in 3, 2, 1. So the first step is to assign the potentials, right? So we'll consider the potential over here as A. Okay, so the potential over here is A, potential over here is B, and then at this junction and this junction, let's assign some potential. We'll call the potential over here as C. Okay, at this point the potential is C, and at this point the potential is D. See, they are not connected by a connecting wire, so they have different potential. Okay, there will be voltage drop across this resistor. So here the potential is C, here the potential is D. Okay, so now step 2 is to draw a simple circuit. Keep in mind that A and B will be the terminals, right? So A is over here, B is over here, okay, and C and D will be somewhere in between, right? Okay, so let's draw the simple circuit now. You can see that this resistor is between, now this point will have potential B, right? It is connected to B. So this point has potential B. So you can see that this resistor is connected between C and B. Okay, so it's connected between C and B. Okay, this resistor is connected between A and C. Okay, so it is connected between A and C. Okay, fine. This resistor is connected between, okay, let's go for this one. This is connected between A and D. Okay, so again it is turning out to be complicated. Okay, seems complicated, but it's a simple thing. Okay, we'll come to know. So it is between A and D, right? This resistor is between A and D. Now this one is between D and B. Okay, so it is over here between D and B, and finally we have C, 1 2 3 4. Okay, finally we have this one. It is between C and D. Okay, so this might seem a little bit complex, but you can note amazing thing over here. Okay, it is a Wheatstone network. Okay, if you see it clearly, you can stretch this and it will form the kite shape, the original shape, and you'll see that it is a Wheatstone bridge. Okay, you can also draw it this way. That okay, I'll draw it this way. Here you have one resistor, here you have one. Okay, here you have another, here you have one, finally here you have one. So each of them has resistance R, 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 R. So you can easily see that this is a Wheatstone network. Okay, so I just stretched A and B. Okay, so what happened is that it became this way. Okay, so here you have your point C, here you have your point D, here is point A. So it is also A over here, A over here. Okay, these 2 points, and here it is B, here it is B, and here it is B. Okay, so you have your point B over here. Okay, so you can see that this resistor is good for nothing, right? It's a Wheatstone network and no current will flow through that resistor because R1 upon R2 is equal to R3 upon R4, right? It's a balanced Wheatstone network, so this resistor is good for nothing, or the equivalent in this case will be simply R plus R, 2R, R plus R, 2R, 2R and 2R in parallel combination will again give you R. Okay, R plus R, 2R, R plus R, 2R, 2R, 2R in parallel will give you R, right? So equivalent over here, the answer is option A, R. Okay, you could have easily seen that instead of doing this, you could have just hold on to this A and bring it out. Okay, hold on this A and bring it out. You can see the original Wheatstone bridge. Okay, you can see it in this form. So when you get it, when you hold A and bring it outside, you can see the kite shape. Okay, here R, 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 again R, and here also R. Okay, so somewhat like this. So you could have easily seen that it was a Wheatstone bridge in first place, and R and R everywhere in a balanced Wheatstone network means that the equivalent will be R. Okay, so our R equivalent is R. It was a little bit different because it was a Wheatstone network. If you had to stop over here getting confused, so sad. Okay, so you had to just think one more step that it was a balanced Wheatstone network. Okay, I think that was our second last problem. Let's move to the last question for the day and then I'll give you your homework question. Okay, so question 6 over here, the last question for the day. Let's solve it. Okay, so the first step is to assign potentials, right? So let the potential over here be A, let the potential over here be B. At this node, we'll assign some potential C. Here at this node, we'll say the potential is D. Okay, so now second step is to draw a simple circuit, right? So treat A and B as terminals and draw a simple circuit. So A and B are terminals. Squeeze C and D between A and B. Okay, and now draw a simple circuit choosing one resistor at a time. So this resistor is between A and B. Okay, this one done. This resistor, let's see, go by the side first. Okay, so AC. Okay, so this resistor is between A and C. Okay, so this one done. This resistor is between C and D. Okay, fine. This resistor is between D and B. Okay, nice. And finally, this resistor is between B and C, this diagonal, right? This resistor is between B and C. So it's over here, right? Okay, so now this is a cakewalk for you, right? It's a very simple circuit. You can see that these two are in series in parallel with this one. Again, this will be in series combination with this one, and that will be in parallel combination with that one. Okay, so R equivalent in this case, I can say first, let's solve this. This will be 2R and R in parallel. If you have been following this channel for a long time, you know that 2R and R in parallel gives 2R by 3, right? R and 2R in parallel basically gives 2R by 3. Suppose you have 10 and 20 in parallel, the answer will be 20 by 3. Okay, so 2R and R in parallel gives you 2R by 3. 2R by 3 plus R, that will be 2R by 3 plus R, that will be 5R by 3. 5R by 3 in parallel with this one. Okay, 5R by 3 in parallel with the R. Okay, so that will give product upon sum. Okay, so 5R by 3 into R. So product upon their sum. So 5R by 3 plus this will be 8R by 3, right? So solve this and this will get cancelled. R and R will get cancelled and you'll have answer as 5R by 8. Okay, I think this is the correct answer. Yes, 5R by 8 is the correct answer over here. I hope the approach is clear. Let's move to the homework question for the day. Question 7 over here, it is your homework question. You can surely give it a try and do let me know the answers in the comment section below. Okay, and it's worthy to note over here that this method has its own limit. Okay, this method is meant for simple circuits in which you are not able to decide which resistor is in series and which is in parallel. Okay, so if you have complex circuits with multiple batteries, that time you won't be able to use this method. Okay, that time you are supposed to go through Kirchhoff's laws or other methods of circuit analysis. Okay, so yeah, this method has its own limit. Use it only when you have a simple circuit wherein you are not able to decide which resistor is in series and which is in parallel. Okay, so yeah, that's pretty much it for today's class. I hope you enjoyed it. If you did enjoy it, smash like. Do let me know a topic which you find confusing, a concept that you want me to cover in the comment section below, and I'll see you soon in the next class. Till then, keep enjoying physics.